They say it had the most incredible architecture, a massive army and navy, and perhaps the most advanced society in the ancient world. And they say it vanished in a single day and a single night. An extraordinary civilization, lost forever.
Atlantis was said to be a legend, a city swallowed by the sea and erased from time. But when AI began decoding fragments from a lost island civilization, something terrifyingly familiar appeared.
Going back 5,000 years, we have sacred texts that tell us there was an antediluvian civilization.
The symbols lined up with myths once dismissed as fantasy, and what the data revealed inside those ancient marks left scientists shaken. The language of Atlantis. Deep beneath the waves, the legend of Atlantis still refuses to die. For centuries, people have searched for its lost cities, its hidden temples, and maybe even its forgotten words. But before we can even dream of decoding a language from that vanished world, we have to ask a simpler question. What exactly would the language of Atlantis even be? To answer that, you have to travel back more than 2,000 years, to a warm afternoon in ancient Athens. It's the late 4th century BCE. Picture a courtyard shaded by olive trees. Philosophers are debating how a good city should live, and among them sits a man whose name has outlived almost everyone else from that age, Plato. In two of his dialogues, Timaeus and Critias, he introduces a word the world has never seen before, Atlantis. That's where it all starts. There's no older mention, no forgotten inscription, no oral tradition passed through time. The first time the word Atlantis ever appears in history, it's written by Plato's hand. Every map, theory, and conspiracy that came afterward grew from this single seed. In Timaeus, Plato has Critias repeat a story once told by Egyptian priests. According to the priests, 9,000 years before their time, a mighty island power ruled beyond the Pillars of Heracles, what we now call the Strait of Gibraltar. That island commanded fleets and colonies across the ocean and reached eastward toward the Mediterranean. Then, the story says, its armies invaded the lands inside the straits, threatening Egypt and Greece. A very ancient Athens stood up to resist and won. Soon after, earthquakes and floods struck, and the great island sank beneath the sea. And just like that, an empire vanished. That's the entire original story. No alien crystals, no superweapons, no pyramid builders. Those details came thousands of years later. Plato's version is clear and purposeful. Atlantis was never meant to be a travel guide or a history book. It was a moral tale. He used it to explore the difference between a city built on virtue and a city built on greed. The first stays steady. The second collapses. His readers would have understood that instantly. To them, Atlantis wasn't a mystery. It was a warning. The part that keeps people guessing comes from what happened next, or what didn't happen. Plato never finished Critias. The text stops mid-sentence, as if someone tore away the ending. There's no lost half of the story hiding in a vault. It just ends. That silence became a blank canvas, and every generation since has tried to fill it. A few hundred years later, the writer Plutarch added a new detail. He gave the nameless Egyptian priest a name, calling him Sontius of Sais. That's not proof of anything. It only shows how later authors like to build onto Plato's frame, adding color and names where he left space. Now we reach the heart of the modern question. If Atlantis was meant as a story to make a moral point, what would a language of Atlantis even mean? We don't have Atlantean books or inscriptions. There's not a single line from antiquity that says, "We are the people of Atlantis." What we do have are real writing systems from the Bronze Age world, the same general period that Plato imagined when he spoke of ancient seafarers, floods, and forgotten kingdoms. Those scripts, carved or pressed into clay, are the only genuine candidates for any lost tongue from that region and time. The closest match sits right in the middle of the Aegean Sea, on the island of Crete. From about 1800 to 1450 BCE, a brilliant civilization thrived there, the Minoans. They built palaces that glowed with painted walls and ran plumbing through stone halls centuries before Athens even existed. And they wrote. Their main script is known today as Linear A. It's a set of tidy, straight-lined symbols impressed into wet clay tablets, often with a stylus made of reed or wood. It's not the same as Egyptian hieroglyphs, though Crete had its own picture-based system too, called Cretan hieroglyphic. Most experts think Linear A grew out of that earlier one and, later on, gave rise to another script called Linear B. Linear B was used by the Mycenaeans on the Greek mainland to write an early form of Greek. But the older Linear A has never been deciphered. This is no fantasy. Archaeologists have found hundreds of linear A inscriptions, made up of roughly 7,000 total signs. They appear on small clay tablets, seal stones, offering tables, and even pottery fragments. Most of them are short, just a few words or a list with numbers. You can think of them as receipts or warehouse notes, the paperwork of a thriving trade empire. And that's what makes them so powerful. They're real, physical evidence of an organized society that kept written records long before the Greek alphabet existed. Because linear A remains unreadable, it attracts wild claims. Some say it hides Hebrew. Others insist it's early Turkish or even Basque. There's no proof for any of that. Scholars can identify patterns, repeated groups of signs, and even symbols that clearly represent goods like grain or olive oil, but no one has cracked the code. The problem is simple, but brutal. The texts are too short, the examples too few, and there's no bilingual version, the kind of side-by-side translation that helped decode Egyptian hieroglyphs. Even so, the system is consistent enough to tell us it was a functioning script, not random marks. Whoever used it knew exactly what they were writing. The world around those tablets was a web of islands, harbors, and sea routes. Crete stood at the center, connecting the Aegean to the wider Mediterranean. Its ships sailed to Cyprus, Egypt, and the Levant. On another island, Thera, what we call Santorini today, a volcano towered over the sea. Sometime in the 17th century BCE, it exploded with a force that reshaped the region. The eruption tore apart the island, sent waves racing across hundreds of miles, and buried the town of Akrotiri under ash. It's one of the largest volcanic events in recorded history. Radiocarbon tests from an olive branch trapped in that ash date it between 1627 and 1600 BCE. The power of that blast can still be read in the soil across the Aegean. Excavations at Akrotiri reveal a city frozen in time. Streets, houses, staircases, even colorful wall paintings of ships and dolphins. And inside that ash, archaeologists found pieces of linear A. That single fact links the doomed island directly to the world of Crete. The same script, the same culture, the same trade network, all alive until the moment nature erased it. The disaster didn't stop at Santorini. On Crete itself, layers of wave-borne debris show where tsunamis hit the coasts. Sediments mixed with broken pottery and marine sand mark how far the water reached. Some traces stretch over 100 miles away, even into what's now western Turkey. The scale was enormous. The eruption and the floods that followed would have crippled ports, destroyed crops, and shaken economies. It's no wonder that later generations might have remembered it dimly as a story of a powerful island destroyed by the sea. That's the real context people point to when they say Atlantis might be based on something true. Here was a rich island culture, centered on Crete, ruling the waves, writing in a script we still can't read, and caught in a cataclysm that changed history. You can see how that might echo Plato's description. But echo is not the same as origin. Plato said his Atlantis lay far beyond Gibraltar, in the outer ocean. Crete sits well inside the Mediterranean. For decades, no one could read linear B either. Then, in the 1950s, a British architect named Michael Ventris, building on the meticulous work of Alice Cober, cracked it open. He proved it recorded an early form of Greek. That moment showed what solving an ancient script really takes. Thousands of examples, careful comparison, and the right leap of logic. It also showed why linear A is still silent. There just isn't enough of it. And the language behind it may not be related to anything we already know. Still, we're not completely in the dark. Artificial intelligence has peeled back a few corners of linear A's secret. Pieces of a lost language awakened by AI. Across roughly 1,500 known linear A inscriptions, adding up to about 7,000 total signs, there's enough data to spot patterns. The same symbols repeat. The same layouts appear again and again. You start seeing a grammar of bureaucracy, even without words. And from that, you can pull meaning out of the silence. Linear A's structure makes sense because it behaves like any organized record-keeping system should. It's consistent, logical, and designed for clarity. The most straightforward part to crack was the number system. That's where modern researchers began. In linear A, whole numbers are written with an additive logic that feels surprisingly familiar. A single vertical stroke means 1. A cluster of vertical strokes adds them together. Horizontal strokes stand for tens. A simple circle means 100, and a circle with little rays drawn around it marks 1,000. When scribes wanted to write a number, they lined these symbols up from largest to smallest, just like we do when we write something like 6,352. If you saw 6,000 signs, 300 signs, 5 10 marks, and 2 1 marks, that's exactly what it meant. 6,352. It's neat, logical, and instantly readable. And once you know that, you can start looking at the trickier part, how they wrote fractions. Those fractions are where the mystery finally started cracking open. In 2021, a research team from Bologna took on a question that had stumped scholars for decades. What did all those small fraction-like symbols mean? They weren't guessing. They combined old-fashioned epigraphy, which is the painstaking process of reading marks on clay by hand, with high-level computer modeling. They even brought in artificial intelligence tools to scan, classify, and test possible values automatically, letting algorithms handle what would have taken humans years of manual checking. The idea was simple. Run through every possible value those little signs could have, test them against the totals on all known tablets, and keep only the combinations that make sense across the entire system. In other words, if every total on every tablet added up properly under one set of assumptions, you'd have your answer. The team used a technique called constraint programming, a kind of AI-guided search that eliminates any solution that doesn't fit the evidence. Then they double-checked the results by comparing them with how other ancient cultures, like the Egyptians and Mesopotamians, handled fractions. The outcome was elegant. It revealed that linear A wasn't random at all. It used at least 17 distinct fraction signs, each standing for a precise value. The symbols had been labeled by modern scholars with letters J, E, F, B, D, K, L, and so on. The Bologna team proved that some of those values were rock solid. The sign called J means 1/2, E means 1/4, and F means 1/8. Other signs filled in with equally convincing logic. B fits as 1/5, D fits as 1/6, and K fits as 1/10. Then there's a small group of L-shaped symbols, L2, L3, L4, and L6, that appear as variants of each other. These seem to mark the tiniest slices, 1/20th, 1/30th, 1/40th, and 1/60th. When you line them up together, you get a clean system that plays beautifully with the base 10 world, but can also divide things into 60ths when precision mattered. That's a huge deal. It means Minoan scribes could handle simple fractions like halves and quarters for everyday trade, but they could also calculate much finer divisions when tracking goods for palaces or temples. If they needed to record something like 3/4, they didn't invent a new sign. They simply wrote 1/2 plus 1/4. That's efficiency, not improvisation. Those symbols don't just float by themselves, they're always attached to something real. On the tablets, these fractions appear next to small picture-like marks called ideograms. Each ideogram stands for a type of item: grain, oil, wine, wool, livestock, and so on. For example, scholars label one of these marks GRA, short for grain. When a scribe wrote the GRA sign and then added the fraction symbol for 1/8, it meant 1/8 of a standard grain measure. Combine that with a place name or a person's name and a whole number, and you suddenly have a record that says, in effect, so-and-so received 23 shares at 1/8 grain. It's bookkeeping, and it works. Every mark means something measurable. The researchers didn't stop at confirming a few values. They stress-tested the entire system, feeding it into their computational model, again using AI-assisted analysis, to see how well it covered day-to-day use. A good numerical setup should handle all the common fractions without breaking. If they tried forcing one sign to mean 1/6 instead of 1/5, totals from real tablets started failing. If they swapped the meaning of B and D, inconsistencies popped up. But when they used the combination they'd identified, every known tablet balanced correctly. That's what made the results convincing. They weren't just tidy on paper, they worked in the wild. There's another layer of beauty in the shapes themselves. Some of the fraction marks from linear A later show up, slightly changed, in the next script that replaced it, linear B, the one used by the Mycenaeans to write Greek. This means that when the Mycenaeans took over Crete, they didn't throw out everything. We might not fully understand what those Bronze Age writers were saying, but artificial intelligence has already brought a different lost voice back to life. How AI resurrected voices buried by a volcano. On a summer morning in the year 79, the sky over the Bay of Naples turned black as Vesuvius erupted, burying the shining villas and the town of Herculaneum beneath tens of feet of ash and fire. One grand house on the cliffs, later called the Villa of the Papyri, took the hit full on. Inside its library, hundreds of book rolls didn't burn to dust. They carbonized. The oxygen ran out, the fire starved, and the papyrus curled into black cylinders that looked like charcoal. They were brittle but still solid. No one realized it yet, but this room would become the only ancient library that survived whole. For nearly 17 centuries, the villa slept under rock. Then, in the 1700s, fortune hunters digging tunnels for the Bourbon kings struck gold, literally and figuratively. They pulled out bronze statues, marble busts, and painted walls that glowed even in torchlight. Somewhere between 1754 and 1758, a Swiss engineer named Carl Jakob Weber sketched what they found and, more importantly, where. In his plans, one room stood out. The men digging there kept bumping into blackened logs that crumbled at a touch. At first, they thought it was wood. Then someone noticed faint writing pressed into the surface. These weren't branches. They were book rolls. By the middle of the 18th century, the count had passed 1,000. Later inventories climbed to around 1,800 rolls and fragments. Even today, much of the villa remains buried under the modern town, which means the rest of that library may still be waiting underground. The first people who tried to read the rolls were artists and curators, not scientists. Camillo Paderni, an artist hired by the Royal Museum, sliced one open, peeled off thin layers, and sketched whatever letters appeared before the next layer crumbled. Each attempt destroyed a little more than it saved. By the 1750s, the king had set up a formal commission and asked for help from Rome. The Vatican sent Abbot Antonio Piaggio, a manuscript expert with the patience of a saint. He built what looked like a surgical fishing reel, tiny silk threads glued to the outer edge of a roll, turned by delicate gears, lifting the papyrus a few millimeters per day. It took years to unroll a single book. Worse, when the papyrus finally touched air, the ink faded almost instantly. Copyists worked beside him, sketching letters as fast as they could before they vanished. Some rolls survived, many didn't. Others were left sealed forever because touching them would have meant losing them. In the early 1800s, science took its first swing. Humphrey Davy, the same British chemist who discovered several elements, arrived in Naples. He experimented with chlorine gas, which made the writing stand out for a moment before the pages darkened again. He managed to read parts of a few dozen manuscripts but admitted the danger. Chlorine could eat paper, lungs, and everything in between. After his visit, the rolls were locked away again. Decades passed, museums traded fragments, and scholars argued over faint letters. By the time the 20th century arrived, the miracle of Herculaneum, a real ancient library, was still almost entirely mute. Then, slowly, the problem began to look solvable. The key idea sounded obvious in hindsight. Instead of opening the scrolls, scan them. In 2016, computer scientist Brent Seals and his team tested the method on a different ancient object, the En-Gedi scroll from Israel. That one, too, was a blackened lump that no one dared to unroll. Using micro-CT scanning, a three-dimensional form of X-ray, Seals mapped every fold inside, virtually flattened the layers, and revealed the hidden writing. In that case, the ink contained bits of metal, so it glowed bright on the scans. The result was breathtaking. Full lines from the Book of Leviticus, read without touching the scroll. Seals named the process virtual unwrapping. The idea spread fast. If it worked on a burned Bible, maybe it could work on the Herculaneum scrolls too. But the Herculaneum rolls hit a deeper challenge. Their ink wasn't metallic, it was made of carbon, the same stuff as the papyrus itself. Trying to find carbon ink on carbon paper in an X-ray image was like trying to see a shadow painted on a shadow. The contrast was almost zero. So the question changed from, can we open it? To, can we find ink where the human eye can't see any difference? The answer lay in texture, not color. When the ink dried, it slightly altered the fibers beneath it. With the right imaging and machine learning, those microscopic clues could be detected. The next problem was geometry. Every roll was crumpled like a crushed cinnamon bun. To read a page, software had to trace the right layer in 3 dimensions, follow it as it twisted, and then flatten it into 2 dimensions without smearing the letters. It was part medical scan, part origami, and part detective work. That was where artificial intelligence finally earned its role. Not by guessing text, but by helping computers see where each page lay and which faint surface marks belonged to ink. In 2023, 2 technology investors, Nat Friedman and Daniel Gross, joined forces with Seals and launched something bold, the Vesuvius Challenge. Instead of keeping the scans secret, they released them online along with starter code and prize money. Anyone in the world could try. The contest broke the problem into 3 steps. Find the page layers inside the scan, detect ink on those layers, and if possible, read real words. The scans came from the Diamond Light Source in Oxford, one of the brightest X-ray machines on Earth. For the first time, an archaeological mystery became an open-source coding race. That fall, a 21-year-old student named Luke Ferreter ran his own AI model on the data and spotted something nobody had seen in almost 2,000 years: a clear Greek word inside a sealed scroll. The word was porphyras, meaning purple. He won the first letters prize. A few days later, another participant, Yusef Nader, posted his own using a similar AI-driven approach and confirmed similar patterns. For the first time, the ancient library spoke, one word at a time. Then, on February 5, 2024, the door finally opened wide. The grand prize, $700,000, went to a team of three, Nader, Ferrator, and Julian Schilliger. Working together, they used a refined AI pipeline to recover more than 2,000 readable Greek characters spread across 11 columns from one sealed roll kept in Paris. To win, they had to produce at least 4 passages of over 140 characters each at high legibility. They more than doubled that. The text they revealed wasn't an account book or inventory. It was philosophy, a discussion about pleasure, moderation, taste, and status. The writer compared simple joy to luxury, even mentioning purple-dyed cloth, a symbol of wealth. Scholars believed the author was Philodemus, an Epicurean philosopher whose works had been found before in Herculaneum. And for the first time since Mount Vesuvius erupted, a voice from that very library spoke again, word for word. The story didn't end there. The organizers of the Vesuvius Challenge kept new milestones on the board for 2025 and beyond, reading larger portions of multiple scrolls, automating more of the work so human experts could focus on interpretation, and expanding the team of historians to identify authors and titles. Media updates already mentioned more columns being read from the same Paris roll and others being prepped for scanning. The goal was no longer find a word. It was recover entire books. If that happens, the buried library could return dozens of lost works to human history. And this approach didn't stop in Italy. The same blend of imaging and artificial intelligence began reviving texts all over the ancient world. DeepMind's system, Ithaca, for example, helped historians repair broken Greek inscriptions by suggesting missing letters and narrowing down where and when a text was carved. When scholars used it alongside their own judgment, accuracy jumped dramatically, and the dating became much more precise. In Mesopotamian studies, AI models trained on tens of thousands of cuneiform tablets linked broken fragments that had been separated for a century. The methods differed, but the spirit was identical. AI didn't replace experts. It gave them new eyes. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.